Hi and welcome to MSc. In this video we're going to be looking at the ambiguous case of the sine law. So let's consider the following values for a triangle, right? We know that side length A is 7 units, C is 10 units, and angle A is 41 degrees. So this is a situation where we know two sides and not the contained angle, sometimes called side-side angle scenario. And if you were to try to sketch out a picture of this, you might get something that looks like this triangle here. And we can see we have angle A is set at 41. We have side C, which is opposite angle C, side A, which is opposite angle A, as is a typical convention. And so if you were trying to solve this triangle, which is a reasonable thing to want to know the other two angles and the missing side length, the first step, and really the only step you can do, is to use the sine law. And so you'd write down the sine law and you'd say that sine C over C, and again, the angle C we don't know, but we know the side length, and sine A over A, and I know both of those values. And then we'd rearrange by bringing the side length C across, and instead of dividing, it's multiplying. We know that value. And then you'd take the sine inverse or arc sine of that to find out the angle. And that can be your first step. So you'd sub some numbers in. C is 10, angle A is 41, side length A is 7, and you'd do the sine inverse of that, or the arc sine, and you'd get an unrounded answer. And then I always encourage my students to round to 3 sig figs. And certainly you'd round to whatever the question told you to, or your teacher had given you instruction to do so. And so based on this, we'd say, okay, well, we now know this angle here, angle C, we said now is 69.6 degrees. Right? And from this, we can then solve for the other missing pieces, right? So this angle up here, angle B, to solve it, I could use angle sum theorem. I'll put AST here. I challenge you to solve that on your own if you'd like. We know that the interior angles of a triangle have to add to 180. And then down here for the missing side length B, we could use a couple options, right? You could use the sine law a second time, or you could use the cosine law as well. And I challenge you to solve this both ways. How you'd actually solve it for a problem might depend on your own personal preference, might depend on what the question asked, or a standard that your teacher has set up. So there we go. We'd solve this triangle, and that would be fine. The question is, though, is that the only triangle that you could make with that information? Most of the time when we're given information for a triangle, we imagine that there's only one picture that we can draw. But is that true in this scenario? Let's go over to GeoGebra and take a look. So here's this same triangle. And if you're not familiar with GeoGebra, it's a great online tool. And I fully encourage you to check it out and play around with it. So here's the triangle that we have. You can see I have already set it up with the answer there that we had for angle C. And we're looking for any other type of triangle we could make here that would still keep the information that we have to have. What we know here is that these sides are set on lengths. So we can't change those lengths and we can't change this angle. But does this have to be positioned right there? Well, if I swing this arm, notice that the angles here is changing momentarily, but I'll bring this point back up to this straight line, and these side lengths are fixed in length. And what we'll find here is, oh my goodness, this is 41 degrees, just like it was, and there is a whole other triangle that we've created. So it could be this one. We solved for this one, but there's nothing saying it had to be that one. It could easily be this triangle. So that means if we go back to our other work, here we have this triangle that we solved, but really there's two possible triangles. And in fact, there are two completely valid triangles for this scenario. So yes, in this side-side angle scenario, there are two possibilities. Now, with the sine law and the ambiguous case, which we're getting into, it's ambiguous as to which one is correct. They're both reasonably correct. And you need more information to be able to say, okay, am I looking at one or the other? In this scenario, this side-side angle, we don't have the angle in between the two sides, right? We know the angle on the other two sides. And it's in that scenario where you might run into some ambiguity leading to the ambiguous case of the sine law. There are other scenarios that can arise that's a little bit out of the scope of this video, but I hope to make another video going over those different possibilities. So look for that in the future as well. So what this generates is we have an acute triangle, and you can see the acute angle here, less than 90. And we have this obtuse triangle, where with the angle we found here was greater than 90. Now, keep in mind that these are both oblique triangles, right? They don't have 90 degrees. They appear both to be scalene triangles, where they have all different side lengths. So one of the first questions that we have to figure out is, how do I calculate this angle here, right? How did I get that? Because obviously we're not going to open up GeoGebra every time. Well, what we'll find is that this angle, the second case and the first one that your calculator will always give you, the acute angle, if it exists, these are supplementary angles. The other angle, and I'll call it angle phi, is going to equal 180 minus the other angle, and I'll call it angle theta. And in this case, this is 180 minus 69.6, which is the 110.4 degrees. So we always have to check to see if we have this. So this one here will sometimes be referred to as the quad 1 answer, because this angle, as an acute angle, is in quadrant 1, and this one will be referred to as the quad or quadrant 2 angle, because this angle occurs in quadrant 2. Okay. Then we can go through and solve the rest of the triangle and get the other pieces in much the same way as we would before. Sometimes you'll get an angle here, and then as you work through the rest of this triangle, you'll realize that you get a contradiction. Something doesn't work, in which case that was not the scenario where you have two possible triangles. So it is possible you get this angle and you work through and then you come up with something that doesn't work. This angle is not possible. But in this case, and in many cases that you'll be tested on, you'll have two completely legitimate triangles that can happen. So how does this happen with the sine law? Why is this the ambiguous case of the sine law? Why does this not happen all the time? So for that, we have to picture our angles in standard position. So I'm going to draw a couple of grids here. We're going to think about this angle in quadrant 1. So here's my angle in quadrant 1. There it is. It's the 70 degrees that we almost got here. In quadrant 2, we have this 110. So it would be off something like this perhaps. And what we know from our work with angles in standard position is we know that this is our theta coming from here, but that's also equal to phi in the first quadrant. This is our angle here. The other theta, I called it phi over here. But we also have this reference angle, and this reference angle is the same as this one here. And what's interesting here is that this happens specifically for sine, because even though your calculator will always give you the quad 1 answer if it exists, we know from the cast rule, cosine is positive there, all of the trig ratios, primary trig ratios are positive there, sine is positive here, and tan is positive here. So we know that theta and phi will give the same ratios, and then in quadrant 2, sine is positive in both. So this leads to the ambiguous case. We don't know which triangle we're talking about, and really, if we're given a side-side angle scenario where there's two possibilities, we need to solve both triangles to fully answer the question. I hope this has helped run through how there can be two possible triangles created from a side-side angle scenario, and that this involves only sine that will generate this ambiguity, because we have to use the sine law as our first step on these triangles. If this has been helpful, please consider liking the video and subscribing to the station. And as always, thank you so much for listening and watching.